So, hello there, everybody, and welcome to this session of the NUI Galway Open Day. In this session, we're talking about physics and climate and exposure science, and I have some colleagues with me from the School of Physics at NUI Galway. We'll talk to you about how to study physics at the university and also how to study on our denominated degree in environmental health and safety. So perhaps just before I invite those colleagues to speak to you and before we have our short panel discussion afterwards, let me just give you a little introduction to how you might study science, but particularly physics and our environmental health and safety degree here at NUI Galway. My name is Gavin Collins. I'm the Vice Dean for Student Recruitment at the College of Science and Engineering here at the university. So there's two main ways to think about studying science at NUI Galway. The first is through our main science degree, our flagship Bachelor of Science degree, and that's GY 301, which along the way opens up 19 different pathways which you can choose to study on. So there's a world of choice here, and you can see in all of those differently colored groups that you'll find something to suit your interests in science. In particular, though, today, we'll think about physics and applied physics and the different options that are available to you in the School of Physics. And as I say, my colleagues will talk you through some of that in a moment. As well as the GY 301 degree, however, you also have the chance to think about one of our 12 other direct entry degrees. So additionally, on the CAO application form, you'll find 12 other BSc degrees. So if I make the slide quite busy and add those 12 degrees to this slide, you'll see here that the choice increases quite a bit. But in particular, an additional option here is our direct entry degree in environmental health and safety. And the director of that program will be here to chat with us in a few moments as well. So to start things off, I'm going to ask my colleague, Professor Gerard O'Connor, who's the head of the School of Physics here at the university, to present briefly on your options around studying physics with us here in Galway. So over to you, Gerard, for a few minutes then.
Okay, thanks, Gavin, for the very nice introduction. Yeah, so I'm going to talk about our physics program at NUI Galway. And our physics program really is one of physics with options. So students can enter this program and they can really begin to think about what their options might be. So the first question you might ask, well, what is physics? And I really like this map that was generated by Dominic Bolliman. And he describes physics as being different regions, if you like. And so your journey through physics using this map would begin on the left here in classical physics. So classical physics, you get to understand how the laws of motion work, what is gravity, what is electricity, how can optics work, what is thermodynamics, and possibly what chaos theory is. In years 3, then you progress into a new field of physics. This is the quantum physics, understanding the physics that pertains to atoms or inside atoms, inside the nucleus, to what happens at nuclear forces. And then in 4th year, you get exposed to another new area of physics. This is the physics that pertains to particles or objects that are moving close to the speed of light. So this is relativity. And using these 3 aspects of physics, we believe you're well equipped then for a future career in physics. So maybe next slide, Gavin. So really, how will you study this area of physics? Well, when you come into physics year 1, we assign you to a particular stream. And that stream really reflects your interest at the time. You may have an interest in astrophysics or theoretical physics, that's physics with maths, or applied physics, that's doing things with physics. Or you might have an interest in physics and the body or biomedical physics. Or this year, we have a new program beginning in physics with climate physics. And so we assign you to these streams A and B, and as you progress through the years 2, 3, and 4, you can change. Your interest in physics may evolve, and our program allows that. And maybe if you get a chance, you can pause the screen and have a look carefully at the options and how these changes evolve with the different years. Next slide, please. So really a key question is, what can I do with physics? This is a question maybe for your parents or your funders. And I guess my answer to this is that employability in physics is a long-term game. And really what physics does is that it helps us to understand at a fundamental level, what are the key grand challenges that our society face? These are the challenges such as climate change, or maybe energy supply, or how we can protect our planet by using all the resources that it offers very carefully. And we do that really by bringing forward new technologies, or these key enabling technologies. And these key enabling technologies are really rooted in physics. So by undertaking a program in physics, you get to understand these key enabling technologies. And so really your career can be at the intersection of these grand societal challenges and these key enabling technologies. Now, our teaching in physics is really led by our research. And we really think we think of it as a process, really, that our students enter from the left here on this slide, and their studies are orientated towards the grand societal challenges. And as they progress through the BSc program that we're talking about today, they may emerge from that and get a job, or they may continue with an MSc program. And the 3 BSc programs that we have in physics are physics program, the science program GY 301 that Gavin was just talking about, and the environmental health and safety program. So that's the key ones that we're really talking today. But there are other programs. And so you will undertake your learning in a research intensive school, which I think is quite exciting. So some of the research we have going on in our school, well, our school has got the largest number of astrophysicists or astronomers of any school in Ireland. And so our astronomers, they go all around the world using the most advanced telescopes to look at space and objects in space to understand the universe better. So in our climate change activity, our physics activities there are really centered on measuring the aspects of climate change. And later in the session, you'll hear more about that. But one of our key jewels in our crown in Galway is that Galway hosts Mace Head. And Mace Head is a global atmospheric watch station and has really got really important data on the planet back into the 70s and earlier than that. So we call it a super site. Finally, in the area of applied physics, I just give you one example. And one example is the activities that we have in understanding the physics that's associated with advanced manufacturing. So a number of years ago, we installed this new advanced pilot manufacturing facility, which brings together laser technology with printed electronics, with printed biomaterials to make the next generation of smart medical devices, or organoids on a chip, if you like, bringing cells on a chip that we can use to evaluate the latest therapeutic treatments for the chronic diseases that persist today. So those are just 3 aspects of our research. So really undertaking learning in a research environment is really what the School of Physics offers this physics program. But underpinning all that are our values. And our values in physics are every student matters. We believe that students need support to undertake this responsible learning and for us to deliver our teaching responsibly and our research responsibly in quite a competitive environment. We want our graduates to have a regional contribution and an international impact. And of course, central to that is how we respect each other and respect the staff that deliver these programs. So physics is also championing gender equality and inclusion and diversity within our school, and we've been recognised with that as a school in earning an Athena Swan Award this year. So finally, I'd leave it at that, and I look forward to answering some questions around the program a little bit later. So thank you very much.
Thanks so much, Jared, for that. So we'll move straight into something Jared had mentioned during his slides, and that is the announcement of a new stream in the physics degree, and this is focused on climate physics. So to speak about that, I'll invite another of my colleagues, Dr. Liz Coleman. Liz, if you'd like to perhaps say a few words then about the new physics and climate physics stream.
Yeah, okay. Thank you very much. Thanks for the opportunity to speak today. And thanks for the lovely introduction, Ger. So, this is a very exciting new development in terms of what is offered here in the School of Physics in NUIG. I mean, we've had a long history of fantastic research in terms of looking into our climate for many decades at NUIG, but now we're offering a chance for students to participate in this field of study. So a degree in physics equips graduates with breakthrough potential for innovation and problem solving. So it's a great degree. And this physics and climate physics pathway will allow graduates to apply the skills that they acquire to meet the grand challenges facing our Earth and our climate systems. So some of these challenges are represented by the UN Sustainable Development Goals. So we all know that our environment is under immense pressure because of human activity, and a major challenge is being able to reduce this pressure by environmental solutions. And education in physics and climate physics will allow us to address these sustainable development goals. So at Mace Head that Ger mentioned, we have a state-of-the-art measurement facility that measures the most pristine air. It essentially measures how dirty or how polluted the cleanest air in the Northern Hemisphere is. So it's situated right at the brink of Connemara, and through our long-term measurements from Mace Head, we can see the effect that various policies have had over the past number of decades. For example, we can see how our efforts to protect the ozone hole has resulted in a reduction in the chemicals that destroy ozone and make the planet a bit less safe. However, we see that despite all the efforts, the global efforts, that greenhouse gases continue to rise. And this is a major problem facing us going into the future. And as long as greenhouse gases are around, that is what is causing climate change. So in studying physics and climate physics, it's hoped that we will be able to come up with some solutions to protect our environment against the damages of climate change into the future. So in order to do that, if we go on to the next slide, in order to be able to predict how changes that we make on Earth might affect our Earth system, we need a complete understanding of the fundamentals of how our Earth system works. And as you can imagine, the Earth system, including the ocean and the atmosphere and all the interactions in between, is hugely complex, and there's many feedbacks and interlinked processes. So this course will allow graduates to have a good understanding of the processes and the mechanisms that affect our environment and threaten our environmental security. So how do we do that? We employ some of the next generation technology. So you can see here we have modeling capabilities that enable us to forecast and predict how our atmosphere is going to change in the coming few days along to decadal scales and climatic timescales. We have advanced instruments that allow us not only to measure air pollution, but also to figure out where exactly that air pollution came from. What are the culprits, be it industry, or is it, as came out recently, a lot of our air pollution here in the west of Ireland is due to burning peat and wood in our home heating systems. We'll also give students the opportunity to study what technology and measurements are needed to understand the atmosphere ocean interactions that are so important to our climate system. And finally, we'll look at remote sensing, which is the use of satellite technology to be able to give information about the state of the planet. So finally, I'll just say what this degree offers. Obviously, when we're looking at physics and climate physics, we're going to give students knowledge and context and experience to develop environmental solutions. And a lot of our graduates will work in meteorology, may work in the policy area, look at measuring our environment or taking the pulse of the planet, environmental protection, public awareness campaign, which is a huge part of our work as scientists, and also forecasting and emergency response. So this would be science for public service, such as response to flooding or severe weather warnings. But in addition to this, we also give our students an in-depth knowledge and training in physics, which means they can apply their physics to any of the areas that Ger mentioned earlier. So that's a brief overview of the physics and climate physics degree.
Excellent. Thanks so much for that, Liz. So we've already covered then how you might study physics through either GY 301, our main science degree, or directly from day one to embark on your physics degree through GY 320. And we've heard about the new climate stream just there from Liz, and all of the exciting ways in which you might think as holistically as you can about how you'll be the next generation of climate scientists and come up with some of the solutions that we'll need to tackle big societal challenges. So also delivered through our School of Physics is a degree which encompasses I guess an intersection between medicine, the environment and exposure science and more. And to talk about that, our BSc in Environmental Health and Safety is the course director, Dr. Marie Coggins. So I'll let you say a few words then with your slides, Marie, on the EHS degree.
Thank you, Gavin. So welcome everyone to Open Day, and over the next few slides I'd like to talk to you about our BSc in Environmental Health and Safety. So Galway NUIG has a long tradition in providing third level education in the area of environmental science and also health, and this programme was introduced in 2001. So our BSc is an applied science programme. It's multidisciplinary and involves input from 3 of the 5 university colleges. It's very much designed to meet the needs of industry today and also to meet the competency requirements that are inframed in the environmental health and safety legislation. Students will study modules on safety, health science, environmental science, and also quality across the 4 years. The programme is professionally accredited, and what that means is that your qualification is recognised not only in Ireland but also abroad and internationally. So what will you study over the 4 years? So in first year, we very much focus on revising some of the basic fundamental science subjects, but you'll also be introduced to some applied topics relevant to the area of environmental health and safety. And we also invite guest lecturers from industry to talk to you about some topics that are relevant to practice. And this continues then also into second year. And then in third year, we very much focus on the core subject material that's relevant to the area of environmental health and safety. So for example, we talk about occupational health and well-being. We also talk about exposure science and measurement of exposures, both in the workplace and in the environment. We talk about the law, the environmental health and safety law, and other topics as well, such as project management, which are very relevant to environmental health and safety practice. Then in fourth year is very much the highlight of the programme for many students, because students get an opportunity to go on work placement. And I'll talk to that in more detail in the next slide. But after work placement in fourth year, students would complete a minor research project. And in many cases, that research project is also completed with the company or organisation that you complete your placement with. So next slide. So as I mentioned, the work placement is very much a highlight of our BSc programme. It's completed in fourth year. So after third year exams, students start their 7-month paid work placement, and then they return to college in semester 2 of fourth year. The placement is organised by the University Placement Office, and students get a chance to, I suppose, use all of the learning from first to third year in a practical work environment under the direction of an EHS professional. We have many placement partners. I've just named a few of those on my slide. There are many more that have been participating in our placement program over the last number of years. And importantly, a question that many ask is, whether or not the pandemic has impacted on our placement. Well, happy to report that the COVID pandemic has not impacted at all on our placement opportunities. In fact, all of our students secured placements last summer, and all of our students are ready to go on placement again this summer. And many of them are assisting employees with the implementation of COVID-19 environmental health and safety matters in the workplace. So once students graduate, what do they do in industry? Well, they've very broad range of roles depending on the sector that they find employment in. But also ultimately, they're managing programs with the ultimate goal of protecting worker health and protecting our environment. And so many end up working in worker health and well-being programs. Others are involved in measurement of a range of occupational or environmental hazards. And in many cases, there's a lot of interaction between or with regulatory bodies where you may be measuring waste or measuring environmental emissions and then reporting those values to the regulatory agencies such as the EPA, or in the case of health and well-being, it could be to the Health and Safety Authority. Next slide, please. So in terms of employability, the programme has an excellent employability rate in Ireland and internationally. In fact, it's almost at 100% employability. Many of our students have found employment at graduation or after their placement, in fact. And they tend to find their first jobs either in the medical device, chemical industry, pharmachem industry, construction industry, or energy sectors. And I suppose the future looks good in terms of employability, in that the environmental health and safety as an occupation has been identified as a key occupation for Ireland's future low carbon economy. So should you have any questions on any element of the programme, please do not hesitate to contact me either through our website, or I provide my email address on this slide here. Thank you.
Great, thanks so much, Marie, for that. So I shall stop sharing now and go back to the rest of you. And I think what we'll use the rest of our time here on Open Day for is to have that short discussion that might answer some of the questions that our viewers might have. So we're also joined by two students from the School of Physics. So we're joined by Jodie, who is or has been a student on the environmental health and safety.
Yeah, I'm just in final year now, so currently.
And also Anthony then. And Anthony, you're also in final year, but you're studying physics, is that correct?
I'm actually in third year physics, yeah.
You're in third year, okay. And just before we start the discussion, which stream have you followed, or what's your focus?
I've streamed into applied physics this year.
Okay, great. So we'll ask you a little bit about that in a few minutes. What I might do though is start off again with Jared, and perhaps if we can just maybe explain to our viewers, Jared, what might be the, say, typical profile of a physics student, or what might a prospective student ask themselves if they're thinking about applying for GY 320 or studying physics on our GY 301 degree?
Okay, very good. Yeah, so I suppose there's no typical kind of profile, everybody's journey is very much individual. I guess we do take really some high flyers who are just passionate about physics into our program. And so people just know that they want to do physics and they come to Galway to do that. And that's one class of student. You have other students then who are really undecided about maybe engineering or medicine or science, and they decide to do undenominated science or the science degree, and they find themselves in the physics pathway pretty promptly. And we're really quite excited about those students because they can pick and match different subjects and journey through physics in that particular way.
Indeed.
And then you have another group of students who probably just feel they're not quite the engineers, or they're not certain about engineers. They want to think deeper and more fundamentally about things. And those are the students that pick the physics program themselves.
So would you say, Jared, then that if somebody isn't studying physics for Leaving Cert, that physics might still be a pathway for them?
Oh yeah, many of our graduates didn't study physics for the Leaving Cert for various reasons. They weren't interested in it at the time, or they didn't have physics in school. And so one of the innovations physics undertook a number of years ago was that we teach physics in first year in different ways. One for the people who haven't done physics before, and one for the students who have done physics. But by the end of that first year, everybody's caught up and they're ready.
Okay. So as a first year student, you could be sitting in a lecture with students who have not done physics, or if you have some experience, you can choose to sit in another lecture where they have previously.
And our best teachers go into the program, into the stream that for the students who haven't done physics before.
Sure, and everybody ends up at the same point at the end of first year, I presume then.
Yeah, that's really important to us. Yeah.
Okay, and just to maybe paint a picture of what the life of a first year student might be like then, I presume that there's not just lectures, but also labs and chances to do practical work as well.
Yeah, so maybe if I just take the denominated physics program, you know, students would do a program in physics, quite an intensive activity. 25% of their activity would be in physics. There would be some mathematics, there would be some programming. And then there would be this discussion class once a week on topics in physics. And students really like that engagement to learn about physics. And then there's also the lab element, and the lab element is really important because, you know, physics is a hands-on thing, hands-on subject. So we really we place a lot of emphasis on that.
Indeed. So perhaps I'll just hop over to Anthony then. So you've gone through this process then, Anthony. Had you physics for your Leaving Cert?
Yeah, so I studied physics in the Leaving Cert. Yeah.
Okay, and your journey then throughout the degree, you took GY 320?
Yeah, I took GY 301 initially. So I left school and I went into journalism. That was my first choice in Limerick. But then I've been doing that for about a year, and I kind of decided I didn't really see myself as a journalist in the future. Throughout my Leaving Cert, I was kind of torn between kind of humanities subjects and science subjects. So I went with humanities in Limerick. I don't think it was for me. So then I left it and I decided to do GY 301, so general science in Galway. I found that was quite beneficial to see these different sciences, to have a bit of experience in biology and chemistry, and decide they also weren't for me, and to go back and decide to pursue physics after that.
Okay, and how did you choose which stream then was for you within the physics degree?
So I think I had always had an interest in doing applied physics. I hadn't really considered doing astro or theoretical or biomedical, the other options. Making things was always a kind of a priority for me. So, from day one of my degree, I kind of had an idea that I wanted to do something in manufacturing with a physics degree, and applied physics is perfect for that.
Okay, and if you were briefly telling someone's granny what applied physics is in one sentence, what would it be?
I would say applied physics is, imagine your normal physics that you're doing in school and have a more focused, hands-on element to it. I think applied physics is much more focused in that direction.
Okay, so you're tackling challenges, I assume.
Yeah, I think so. For me, I always like tackling kind of problems or challenges in a field that's kind of tangible to me, something that I can see and hold and kind of observe what's happening with it.
Okay, and lastly then, Anthony, what would you say has been the most enjoyable part of the degree? What have you found you've enjoyed most?
I found I've enjoyed the lab element of the degree a lot. That was interesting for me, I think, because I didn't really enjoy the lab element of physics in school. I didn't really find it was so engaging, but from doing it in university and NUIG, I've really enjoyed all the labs I've done. I feel like I've learned a lot from it. It is great to kind of tackle these problems in the labs with like a lab partner, and you kind of have this kind of peer-based learning. I think it's really, really beneficial for me.
Indeed, indeed. And by the way, you'll be doing a project then next year. You'll be doing your final year project.
Yeah.
Do you have any idea what that may be on?
Yeah, I do actually. Actually, from Jer's help, I'm doing an internship with the Tyndall Institute in Cork this summer, and I would like to kind of use some of that work from my internship this summer in my final year project. So my internship is kind of focused on light-based technology and materials, specifically in like microchips. So I think I would like to bring that forward into my FYP for my final year project if possible.
Sounds great. So I hope it goes really well for you.
Thanks.
Maybe I'll move on to Liz then. So Liz, you had told us a little around the new stream in climate physics. Why are we introducing a new stream in climate physics?
Well, I think now more than ever, the problems with our environment are becoming apparent, and especially there's a huge youth interest in and drive to become part of the solution. So it's an opportune time. As I mentioned, in the School of Physics at NUIG, we have a long-standing kind of world-renowned history of climate science, and really we've been punching well above our weight nationally by producing some of the finest research that tells some of the secrets of how our atmosphere is changing and give insight into some possible solutions. So I think it just seemed like a really good time to bring our research together with the appetite for climate solutions in our youth.
Indeed, yeah. And you know, I imagine that many of the people watching will be really motivated by the Sustainable Development Goals of the United Nations and will be inspired by the idea of meeting some of these grand challenges. But they mightn't think that physics would be the first subject to cross their mind in meeting these big challenges and problems. So why is physics an important subject when it comes to understanding climate and sustainability and tackling these big problems?
Yeah, that's a good question. Well, I mean, fundamentally, climate change is all about how the world uses the energy that we get from our sun. And like physics is the study of energy and matter. So if we are to understand how our climate is going to change in response to any changes that we make in society, we really need a robust understanding of how our atmosphere is interacting with solar energy. That is the crux of climate change, really. And I think an understanding in physics is vital if we are to have any sustainable futures or sustainable kind of solutions for our environment.
Indeed, indeed. So if somebody likes the sound of all of this, how can they get onto the climate stream then?
Well, I think by getting in touch with the School of Physics, and the climate stream is, I think, the fifth stream in GY 320. So it is a denominated climate stream, a denominated physics option stream.
Okay, so anybody interested should also check out GY 320, and there's a course webpage which will explain all of the nuts and bolts of that degree and the subjects that you'll do from year to year. But the climate stream is one option or component as part of that degree then.
Yeah, and we're very happy to answer any queries from students. So.
Excellent, yes. So they can ask a question directly from the webpage as well, and the email will go to your school.
Of course, yeah.
Great. So I think perhaps we'll move on to environmental health and safety at that point. And Marie, so thanks for giving us the introduction, Marie, in your slides. One thing that struck me was the placements you mentioned and the fact that during the COVID-19 crisis that all of the students still found placements. So clearly there was a big need for their skills and the activities that they were engaged in on those projects.
Yeah, so as we all know, the world of work has really changed in the last year and a half, and I suppose many of us have worked remotely, but others have had to return to work, and in returning to work we had to make sure that our workplaces have been safe. And a number of different measures have been implemented to ensure that, whether it's social distancing or around masking or assigning the correct respirator, depending on whether or not you're performing tasks where there might be an increased risk of infection transmission. And so the EHS professional in practice has very much a leading role in, I suppose, designing these programs to ensure the safety and health of the worker. And so our students have played a very active role in helping these professionals implement the necessary practices on the ground across all sectors. So, you know, some sectors have more challenges than others. So, you know, healthcare sectors, but also, you know, our food processing sectors in particular have had, and construction industries have had a lot of challenges in the last year. And so our students have really helped a lot in those sectors on their placement.
Indeed. And could you tell me, usually how many students do you take on to the EHS degree?
Usually we take between 15 and 20 students into first year. And then we may have 1 or 2 students joining us then later on in the program from other streams as well. So it's a small group, which is great. Everyone gets to know each other very well and work as part of a team.
Indeed, which I think sounds really attractive indeed. And say if there was one misconception perhaps about the degree in the minds of prospective students, what would you say that might be?
Well, I suppose a lot of students don't realise that the BSc is actually a science degree, and the good thing about the programme is that it's very multidisciplinary, and so you are really getting what I would think a taste of all the different sciences. And you know, when you get to third year, along with completing the work placement, even upon graduation, I mean, there are lots of opportunities to go into employment straight, but after graduation, but you also can diversify into a range of other areas because you would have completed, you know, the foundations in so many different subjects from first to fourth year. So many of our students that do go on to study postgraduates can study areas such as diverse as fire safety, or they can go into public health, or they can go into you know, other aspects in engineering, etc. So, you know, obviously there are lots of employment opportunities, but you get such a broad overview of such a range of different topics that are relevant to environmental health and safety, that if you decide you'd like to do a postgrad, you know, there's many opportunities there also.
And perhaps just because our listeners might be interested, what briefly is your own research focused on, Marie?
Okay, so I'm based in the School of Physics, and I'm an exposure scientist, and I suppose my area of research is very much around measurement and to understand the level of exposures that we get to many different occupational hazards, whether it's in the workplace or environmental hazards. And the reason we want to understand you know, our exposure is to understand risk, and then to put protective measures in place to reduce risk and improve health. So we have a number of ongoing projects at NUI Galway looking at exposures at home, from measurement both in, as I said, occupational horticultural settings, but also more widely, you know, the environmental exposure to pesticides, either through our diet or through ingestion of polluted water, for example. So we will get, you know, so students will get an opportunity to, you know, in fourth year to work with either me in our exposure science subjects, but other staff members as well who are involved in other areas of research relevant to EHS.
Indeed, yes. So there's a diversity of different topics that they'll study in lectures, but also have a chance to do a project on everything, I guess, from exposure right through to the quality aspects and other areas that you'd spoken about. Lastly, Marie, just to confirm for our viewers, the CAO course code is GY313, isn't that correct?
Correct, yes. Yeah.
Okay, great. I'm sure people might be interested to meet a student on the EHS degree. So Jodie, welcome back. Perhaps you could tell us, just as I'd asked Anthony, what you've enjoyed most about your time on the environmental health and safety degree.
Yeah, no bother. So I think the degree is a really nice thing because, as Marie said, like, it's a small class. you really get to know everyone. We all like kind of stick together and we help each other out and stuff, which is really nice when you're in like a big university and the courses are so big and stuff. So it's nice to have that little small group. I'd say probably the best part about the whole course now was the placement that I got to do just in the last few months. It kind of let me see the industry. It let me like tie everything together from like what I was doing from first year up to third year. And I got to see like why we were doing it. It made it relevant to me. Also, my area was in pharmaceutical, so I got to have a look at that. But if I didn't like that, I could have said, oh, well, I might try construction or agriculture or something else. But it gives you like an insight into seeing kind of what area you might like to go into, which is really, really good, I think, because obviously it's hard to make your mind up when you're kind of finishing up and decide what area you want to go into. So I think the placement time was very good.
And how had you chosen in the first instance to join the degree? What was the main motivator, or what helped you make that final decision?
Yeah, so for me, I always loved Galway and NUI. I went to the open days and I said, like, this is the college for me. I want to go here. So that was kind of my mind made up. But for me, it was really important to get a course that I was going to get employed in after, because I know sometimes people go in and they do a college course and it doesn't work out, or there's no employability at the end. So for me, that was really, really important. So when I went to the talk and I heard that almost 100% of students were employed after, that was really a big aspect for me. Also, I'm from a fireman background, so health and safety is obviously really prominent for us. So I had an interest there. When I seen the different kind of subjects, like you're doing law, you're doing health science, you're doing sciences, you're doing engineering, there's such a wide variety of things. So there's kind of something for everyone. And I just thought that, yeah, I really was kind of interested in it. So yeah.
Excellent. So you have your final year exams coming up now, isn't that right?
Yeah.
So, I think we should let you get back to do some study then.
Absolutely, yeah. Thanks, Gab.
With that, I think I'd like to just thank everybody for joining us on this session. So thanks to Ger, to Liz, to Marie, to Jodie, and to Anthony. And I guess I would just say that I hope everybody enjoys the rest of the open day, and that you might be able to join us for our Q&A session later on Pubble. So with that, thanks very much and goodbye to everybody.
Goodbye, everyone. Yeah, and thanks, Anthony and Jodie. Yeah, and Liz and Marie.
Thanks, everyone.
Thanks, Dan.
Bye.
Bye.
Cheers.